Hello students, welcome to our channel. In order to know the electronic configuration of the elements, quantum numbers are very much essential. Now, what is quantum number? There are 4 quantum numbers, you know, n, l, m and s. N is the principal quantum number, L is azimuthal quantum number, M is magnetic quantum number and S is spin quantum number. Now, these 4 quantum numbers are required to express the position of the electron, the momentum of the electron and the energy of the electron. Everything regarding the electron can be judged by the 4 quantum numbers. And why this periodic table I have given? It is very easy to locate the element from the periodic table, and once we know the position of the one element in the periodic table, then it becomes very easy to know the quantum numbers. Now, example question is the correct set of 4 quantum numbers for the valence electron of rubidium atom whose atomic number is 37. These are the 4 options. Now, rubidium, if you will see in the periodic table, it is coming in the 5th row, that is n is equal to 5. Now, principal quantum number directly we can write, that is n is equal to 5 for the rubidium. Second, azimuthal quantum number. Azimuthal quantum number, this is L and you know its value is 0, 1, 2, 3 like this, and 0 is for s orbital, 1 is for p orbital, this is for d orbital, this is for f orbital. So, here for this rubidium, if we will calculate, n is equal to 5, L is equal to 0 since it is having s orbital. Now, m, for m value you know, m value is equal to minus a, m value is equal to minus L through 0 to plus L, and since L value is equal to 0, for s orbital m value is equal to 0. So, this m value will be 0 for the rubidium atom. Then spin, 1 electron is there, so it will be plus half. If you will see 5, 0, that means n is equal to 5, L is equal to 0 for s orbital, and this is m is equal to 0 for s orbital and plus half. So, this will be the correct answer. These answers are wrong because here you see n is equal to 5 given, s is given, but m is equal to 1, which is not possible for s orbital, it will be 0. Similarly, other option is also not correct. Question number 2, the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Now, if you will see the last one is 3d5, 4s1, this represents the excited state, ground state, cationic form and anionic form. And you see this element 24, it is your chromium, which is a 3d5 and 4s1 system. For chromium, if you will see chromium 24, so its electronic configuration 3d, 4 and your 4s 2. Actually, this is coming to be 3d 4, 4s2, but if you see the ground state, it is not so, it is your 3d 5 and 4s1 system. Why it is so? Because this 3d 5 and 4s1 system, it is more stable than the other one. Now, question is why it is more stable? It is due to the exchange energy. Now, question is what is exchange energy? Now, let us see what is exchange energy and how it is responsible for this electronic configuration. Now, you see, if you will see 4s2 and this is your 3d system, you know 3d, d is having 5 orbital. So, d1, d2, d3, D4, D5. There are 2 electrons in 4th orbital, 4s2, and here 3d4, originally it is 3d4. Now, there are 4 unpaired electrons. We are writing in this way. We have not written this in the form of like this. It is, we have not written like this. 2 here, 2 here. It is wrong. Similarly, other configuration 1, 2, 3, 4, 5. This 1, 2, 3, 4. This is also wrong, because maximum multiplicity is always acceptable. So, electrons are arranged so that there will have the maximum number of multiplicity. This is called Hund's rule of maximum multiplicity. This is called Hund's rule of maximum multiplicity. Now, you come, this is D4 system, this is 4s2 system. One electron from this, if it will come to this higher orbit, this 3d orbital, then now the electronic configuration will be 3d5 and your 4s1. Now, from this we want to show how to calculate the exchange energy. Now, exchange energy means when 2 electrons are of the same spin are inter-exchange, when they are exchanged, suppose this is electron 1, electron 2, electron 3, electron 4, electron 5, then this electron can be exchanged with this electron. So, one electron has the 4 option, because here there are 5 electrons. How many exchange can be possible, and what will be the exchange energy? Let us calculate for this D5 system, because it has been, we have assumed that one electron has been jumped and it has become now D5 system. 3, 4, 5. Now, suppose this is electron 1, electron 2, electron 3, electron 4, electron 5. Now, electron 1, these are all having the same spin. So, it can exchange with this, it can exchange with this electron, it can exchange with this electron, it can exchange with this electron. So, electron 1 has 4 exchange options. Now, similarly, if you will see electron 2, it has 3 options, 1, 2, 3. So, electron 2 has 3 options for this exchange. Now, electron 3, 2 options, electron 3, it is having 2 options, it can exchange with this, it can exchange with this. Then electron 4, it is having only 1 option with E5, so it has 1. Now, total number of exchange is equal to 4, 3, 7, 9 plus 1, that is 10 exchange. That means, for this 10 exchange, the exchange energy will be equal to 10 E. And since the exchange energy is release of energy, it causes the stability. So, it releases the energy, energy becomes less, and the sign is given minus 10 E. So, this is having the minus 10 E, the exchange energy, the extra stability, it is responsible for the extra stability of the D5 system. Now, if we will consider 4s2 and 3d4, then let us see what is the exchange energy and why this system is more stable than this. Now, if you will see D4 and 4s2, exchange of electron takes place only in the degenerate cell. This unpaired electron cannot be exchanged with this, only this degenerate energy orbitals can exchange the electron. Now, if there are 4 electrons, then the exchange energy will be for the system 2, for 4 electron, E1 can exchange with 3 only, because there is no option. So, E1 is equal to 3, E2 2, E2 2, and E3 only one option. So, E3 is equal to one option. So, 3 to 5 plus 1, it is equal to 6. So, here 6E exchange energy. So, this exchange energy is more than this exchange energy. So, D5 is more stable means it is in the ground state, neither it is in the cationic form nor anionic form nor in the excited state. So, your answer will be ground state. And you see the same question is asked in a different way. The correct ground state electronic configuration of chromium atom Z24 is equal to this. And you know the system is D5 4s1. So, before that argon will be there, okay. Electronic configuration if you want to write, then we prefer to write the inert structure, then the rest of the electrons can be arranged in this way. So, this is your right answer, question is same. Always this type of question always comes, it is very important whenever you will see chromium 5 system and copper 10 system, it is always coming in the exam. So, by the help of exchange energy you can explain which is more stable. The next question, then the correct set of quantum numbers for the unpaired electron of chlorine atom is how much? So, chlorine you know its atomic number is 17, and if you will see the electronic configuration, before that what you are having, suppose you are writing neon, it is your 10, then 7 electron you have to arrange. So, 7 electrons you will arrange means here P5 and S2. So, S2, which S2 and which P5? Neon, if you are writing the electronic configuration, 1s2, 2s2, above principle if you are applying, 2s2, 2p6, 3s2, 3p6, 3d, 10, 4s2, 4p6, 4d, 10, and if you are writing the electronic configuration, 1s2, then 2s2, 2p6, 3s2, and how much is it is 2? It is 2. First cell 2 electron, then S2p6 it is your 8 electron, 3s2, 3p5. Okay. Now, question is the correct set of quantum numbers for the unpaired electron of chlorine, unpaired electron. So, 3p5, in the 3p5 you are having unpaired electron is this, okay. So, px, py, pz suppose you are taking, then you are having the answer. N is equal to 3, principal quantum number, okay. For the valence electron it is 3p. So, here N is equal to 3 and P for P, L value is equal to 1, M value is equal to minus L through 0 to plus L, means you are getting minus 1, 0, plus 1, plus 1. So, your quantum number if you see N is equal to 3, L is equal to 1 and M is equal to 1. This is your answer. Okay. So, from this electronic configuration you can know very easily. Then question number 5, the outermost electronic configuration of the most electronegative element. Most electronegative element you know, they are in the halogen groups, fluorine, chlorine, bromine, iodine like this. The most electronegative it is fluorine and it is your outermost 7 electrons, fluorine is 9. So, 1s2, 2s2, 2p, obviously it is 5. So, the outermost electronic configuration of the most electronic element it is equal to, if it is N, so it is NS2 NP5. okay, outermost, we need not consider 1s2, outermost is your equal to your 2s2 2p5 per fluorine. For chlorine it will be 3s2 3p5, for bromine it will be 4s2 and 4p5 and so on. So in general it will be ns2 np5. So this is your correct answer, ns2 np5, 7 electron system. It is just before the inert gas element. So this is the correct answer. Next, maximum number of electrons that can be accommodated in the cell with n is equal to 4. Now n is equal to 4. Number of electron for n is equal to 4, it is equal to 2n square. So n square is equal to 2 into 4 square, so it is equal to 32. Clear? So this is your answer, 2n square. So maximum number of electrons will be 32. Next, the number of orbitals associated with quantum numbers n is equal to 5, ms is equal to 2. Now number of orbitals associated with quantum numbers n is equal to 5. Now we have seen that n is equal to 5 means maximum number of electrons is equal to 2n square, that is equal to 2 into 5 square, that is equal to 50. Now you know one orbit has the maximum capacity to accommodate 2 electron. One orbital here, if you are saying px, that it can accommodate maximum, this is your orbital, px orbital, py orbital, pz orbital. So one orbital has the maximum capacity to accommodate 2 electrons. So question is the number of orbitals associated with quantum number n is equal to 5. So how many orbitals will be there? 50 electrons are there, so 25, because one orbital maximum accommodate 2 electrons. So here the correct answer will be 25, because 50 electrons can be accommodated in 25 orbitals, because by 2 it is equal to 25. So the answer is A. Next, the azimuthal quantum number means L, okay, for s orbital. For s orbital, azimuthal quantum number has been asked. That means out of 4 quantum numbers, L value has been asked. The azimuthal quantum numbers for the valence electron of gallium. Now if you will see in the periodic table, gallium is 31. Now in the question it is given gallium plus, means 1 electron less. 1 electron less means if you are removing 1 electron, 31 minus 1, then obviously it will be 30. It is coming to be 30. 30 means it is a system of zinc system. What is the configuration of zinc? So if you will see 4s2, for 30 it is 4s2 and 3d10. 4s2 and 3d10. This is for zinc. This is for zinc, and it is also equal for gallium 2 plus. Gallium 2 plus having 30 electrons each, they are isoelectronic. So the electronic configuration will be also same, 4s2 and 3d10. Now the azimuthal quantum number for the valence electron, outermost electron. Here out of these 3, this is the outermost, because it is 4, this is 3. So outermost electron is 4s, and for s it is L, so it is L value will be 0.